there a clicker? All right, cool. I teach in a room that's like 3 times the size of this, and I don't use a mic in there. So Partha, you yell at me if I fail, but I think I'll be all right. Title of the paper, Mental Health and the Early Career Dynamics of Young Men, CC and her co-authors. If anyone's feeling a little bit of deja vu, it actually is appropriate. I have presented a paper at this conference one other time, and it also was a dynamic structural model that CC had written. She graciously again shared her slides, so anything good that you see in the slide deck, she's responsible for and not me. Okay, motivation for this paper, similar to the last one. Mental health disorders, they're highly prevalent early in life, both in the UK and in the US and in Australia, which is the context we're going to be looking at. About 20% of men under the age of 30 will report some evidence of mental distress annually. In their data, they have a special definition of poor mental health, and by age 40, 60% of their sample has at some point experienced mental distress. In this literature, actually in this room, by people in this room, a lot of ink has been spilled on the topic of the relationship between physical health and labor market outcomes. And you can think that relationship's unique in that people tend to go through physical health declines later in life. And so the way in which that influences labor market outcomes is through decisions like, when do I retire? Here we have a health condition that similarly could influence people's labor market outcomes, but it's going to happen earlier in life and could even influence things like schooling decisions. Okay, so the key question that CC is interested in here: how do mental and physical health dynamics shape schooling, work, and career decisions of young men? They're quick to point out that there's a couple key identification challenges when you're studying this topic. One being that there's a reverse causality issue. If I see some negative correlation between mental health and labor market, is it the case that health is influencing labor or vice versa? There's also kind of an initial conditions issue here that, like, we would expect whenever we pick somebody up in the data, if it's the case that they've lived some sort of disadvantaged life, I might expect that they're more prone to mental health issues later, but for the same reasons, they may also be more prone to negative labor market outcomes. Okay, so that's something that they're gonna have to deal with, both of those issues, and they're gonna do so by developing and estimating a life cycle dynamic discrete choice model. The key features of the model is they're gonna endogenize health, schooling and work, and then also the income process. And a key way they're going to address these endogeneity concerns is through a combination of kind of exclusion restrictions and modeling of observed heterogeneity. Okay, so to get into the data they're going to use, they're using the Australian version of the PSID. So 17,000 Australians interviewed every year. Because they want to look at specifically at men early in life, they're going to, and because it's a panel, so they have to throw away a lot of data where they have missingness, they're going to whittle that down to 2,300 young men who have all graduated high school and where they can get a reasonable idea of what the beginning of their career looks like. A key data source or key fields in this data set is that all of these individuals answer 36 questions about their health. Some of those questions you can create an index of mental health from. Some of those questions you can create an index of physical health from. So they have kind of 2 continuous measures, one of mental health, one of physical health. Ultimately, because they're going to estimate a dynamic discrete choice model and they would kind of corral their state space, they're going to end up defining binary indicators of being in good or bad mental health and good or bad physical health. Okay, this is the first place that I'm going to jump in with. I have like 2 what are pretty minor suggestions that I think actually you could get a lot out of. The first being, you start people at 18 who have all graduated from high school. Like, it's conditioned that they have to graduate from high school. It doesn't change your model at all if instead you have them start at age 15, or at a minimum include those who are high school dropouts. So there's a couple reasons for this. One, if you look in Australia in aggregate, among folks right now who are between 20 and 24 years old, it's literally 20% of the population hasn't graduated from high school. And actually in your sample, if I'm reading it right, it's more like a quarter of the sample you're losing to people by saying that they need to graduate from high school. This is like a clear channel through which early life mental health shocks could lead to a decrease in lifetime earnings through not attaining a high school degree. I was curious, so I went and looked at some data that I just had on my computer from the MEPS. I looked at folks who were under 30 years old. and separated those who had graduated from high school and those who hadn't. And actually, there were twice as many people reporting some measure of mental distress among those who hadn't graduated high school than those who had. So it really is the case that, like, it might be that a substantial chunk of the people who are dealing with mental distress early in life end up in this group that you're throwing out of data. Okay, so I think it's an easy change. Another easy change, like, you have this continuous measure of health. Anytime somebody's estimating a model like this, we discretize these continuous measures. For convenience, it allows us to estimate models faster, and we have to make a decision about, like, how many discrete categories are we going to allow. I think there's a real reason for, at least with mental health, for you to allow 3 discrete categories instead of just 2. And it pertains to, like, where you can place this in the literature. So if you go back and you look at kind of early reduced form work that's examining the effect of mental illness on various labor market outcomes, they tend to find really big effects. Part of the reason they find really big effects is because, like, correlation, causation, they're using older methods. But I think the bigger reason that they find big effects is because they're looking at more severe cases of mental illness, simply because the way in which we define mental illness has changed over time. Like, almost all of the growth that we talk about in mental distress is people who are dealing with kind of mild to moderate depression and anxiety that previously we just didn't say that they had a mental illness. Okay, so again, by allowing these 2 groups, when we think about the effect of mental health on labor market outcomes, you're confounding these 2 groups right now, and I think it would be really nice to separate them. Okay, despite the fact that they have this kind of one dichotomous definition of being in good or bad mental health, they do see a ton of persistence in the data. So in the image on your left, we're looking at transition probability. So given that somebody's in good mental health or good physical health, what's the probability that in the next year they will still be in good mental health or good physical health? The blue line's physical, the red line's mental. You can see that across the lifespan, really, until we get up to, like, roughly 35, like, if last period you were in good health, next period you're going to be as well. I turn 40 next month. The drop in the blue line's pretty terrifying. Maybe more interesting is on the right, we're looking at conditional on being in bad health. What's the probability that in the next period you're still in bad health? And here we see a pretty big difference between physical and mental health. If it's the case that when you're young, you have a period where you're in bad health, in all likelihood, you're going to move out of that state in the next period. But there's much more persistence in poor mental health at young ages, right? So it's something that can be explained by a model like this, but also means that we would expect there to be some labor market implications. Okay, this is just showing, again, from the raw data, how different health states can potentially influence different labor market transitions. So the first big red number in the top left corner, that 85, that's saying if I had a full-time job in period 1 and I was in poor mental health, what's the probability that I have a full-time job in the next period? 85% of the time I'm still gonna have a full-time job. If I'm in good mental health, that jumps to 92%, okay? Moving to the right side of the top panel, we're now looking at if I wasn't working in a period, what's the probability that I'm still not working in the next period? If I'm in poor mental health, that happens 72% of the time. If I'm in better mental health, then half the time I'm moving out of the not working state. So again, some evidence that these health conditions are influencing these labor market transitions. Okay, so let's jump into the model. We've got a life cycle model that's going to start at age 18. At the beginning of every period, the agent's going to know how many years of education they have. They're going to know their experience, whether or not they're in good mental health or bad mental health, and whether or not they're in good physical health or bad physical health. Once they enter the period, they're going to receive a preference shock that will lead them to make a choice. Either they're going to go to school, which they can do up to age 25, or they're going to work full-time, part-time, or not at all. After they make the work decision, they're then going to get a wage shock, which is going to determine their consumption in that period. And then after they get the wage shock, they're going to get what's called, and I'll talk about this a little bit more later, a life shock. Think of this as being something like learning that your mom was sick or learning you had a friend die, something like that. Something that would then influence your physical and or your mental health, and then there's going to be a shock that determines which health state you transition to. Okay? I'm going to start by thinking about the wage equation and the health transition. So at the top here, we have the wage equation. They're going to make your period T wage a function of your mental health, your physical health. G is your schooling, and X is your experience. The health transition, health is going to be a function of health last period, this life shock that I just talked about, that I'll talk in more detail in a second, your labor market decision, so deciding to work full-time or not can influence your health transition, your income, and then also your years of school, okay? We talked about this reverse causality issue, right? So one way they want to account for that is they want to allow the unobserved determinants of this income process and the health process to be correlated with one another. They're going to do that with these unobserved types that they're going to estimate. So think to yourself, there's going to be a high income and a low income type. There's going to be a high health and a low health type. That gives you 4 unobserved types in total. For everybody in the data, they're going to estimate the probability that that person is of each one of those 4 types. And they're going to allow the probability that somebody is of each of the types to be a function of their family background and their initial wealth. Okay? We'll then have a flow utility. Think of the first term as basically being like some function of their income. And then basically the rest of the flow utility is just going to be direct utility of work and schooling. So the first term, the first 2 terms at the top, that's just the utility or disutility of the different work and school decisions. Then we're going to, with the first red term there, we're going to interact those with health. So in other words, the way in which your health influences your utility is it changes the relative utility you get from working compared to staying at home. Okay, so in other words, if you're healthier, you might like working more. If you're healthier, you prefer work to stay at home more than if you were unhealthy. Okay, and then the final term, the stayers benefits, that's just like a switching cost. That if you switch between these work decisions, you pay some cost between. Okay, this is all like, for people who estimate models like this is all like very straightforward. We can define a value function. They're going to make these school work decisions to maximize the lifetime expected value of those decisions. It's a finite horizon problem, so they're going to solve it backwards by making some error assumptions, some distributional assumptions of the error term. That leads to a likelihood function, and they're going to estimate this via maximum likelihood. So this part's pretty straightforward. Now there is one thing in here that's kind of important. If you notice, there's no unobserved heterogeneity in the utility function. The whole solving the problem backwards, you need to solve the problem backwards to calculate value functions. So if the unobserved heterogeneity is outside of the utility function and outside the backward solution part, that means that they can estimate the wage, the health, the life shock, and the unobserved heterogeneity part first, outside of the backward solution. Then they have those parameters. Then they can solve the model backwards to estimate utility function parameters. And what it means is they don't have to iterate over all of those other parameters when they're solving the model backwards. So it makes estimation go a lot faster. Okay, so with that, let's talk about some identification concerns. So I'm getting an assist from Mike. I don't know when I first read this paper, but Mike has a paper in Econometrica, and in the identification section, the very first paragraph of the identification section says, in complex dynamic models, it is well known that formal proofs of semiparametric identification are infeasible, so it is standard to rely on heuristic arguments. And when I read that, I was like, yes, he said it, now I get to say it, and nobody can get mad about it. So what do I think Mike means about heuristic arguments? And this is how I interpret it. I think what it means is that, like, we ignore nonlinearities in the model, we ignore timing assumptions, we take the model and we go back to like simultaneous equation modeling, and we think about where are there endogenous variables on the right-hand side, and that's going to give us some intuition for what errors need to be correlated and where we need exclusion restrictions. So let's start with what Cece's actually doing. She's allowing for such error correlation between the income process and the health process because she's worried about reverse causality. And so in that setting, what do we need? We need error correlation, which they're allowing, and we need an instrument Z to identify the effect of health on income. And they take that part very, very seriously. So there's a big chunk of the paper that like looks like a reduced form part of the paper where they do like an event study. All right, so what is their instrument? What's the thing that's going to influence health, but only influence income through health or wage through health? It's going to be this life shock. So they can see in the data if somebody has a death of a friend, they're a victim of a property crime, they're a victim of physical violence, they have a serious illness of a relative, or they have a death of a relative, there's information about that in the data. And actually, in a quarter of the periods, in a quarter of the individual years, people have one of these. Okay, so that's going to be their instrument for health. They're going to do outside the model like a standard event study to try to convince people that like this is a reasonable instrument, and this is what the event study plots look like. So the vertical axis is on the left is good mental health, on the right is good physical health, and you can see when people experience these shocks, we do see a decline in their health. Okay. Within the context of structural paper, it's great to have something like this. This is nice. I'll pick at it just a little bit. The way I'm going to pick at it is, if you look at these 5 things, only one of those should lead to a change in physical health, and that's the one that's least pronounced, the victim of physical violence. All the other things that would be shocks to mental health, and only mental health, I would presume. So the fact that we get such a big effect with physical health, that gives me like a little bit of pause about thinking about this as like a really great exclusion restriction. Okay, so that's one thing I'm gonna pick on. The other thing I'm gonna pick on gets back to this like simultaneous equation modeling, which is there's not one measure of health, there's 2. There's mental health and there's physical health, which would mean we need not one instrument, but we need 2 instruments. But I think given that you're like building this instrument out of 5 variables, like it would be easy for you to separate that violence variable out, and now you have 2 instruments. Okay, so pressing on, you paid a lot of attention to the effect of health on income, but not much attention to the effect of income on health. So income is on the right-hand side of this health equation. So we also need an exclusion restriction for that. It is the case that like experience is entering the income equation, but like that's pretty endogenous, so maybe you want to look for something else. And then also the DM, that's the work decision, is like a clearly endogenous thing that's on the right-hand side of the health equation, and you're not like accounting for that at all right now. It's also the case that the estimate of the effect of working on mental health, and I'll show you this in a second, is really, really big. And that's kind of cause for concern that like, yeah, it's big because we're not accounting for the endogeneity. The second concern related to this, I'm like literally just lifting text from Mike's paper. This is the sentences that follow the first 2 that I showed. He describes in his paper that like you can think in his paper, this is like a standard like Heckman style labor supply model, and we can think about, even though it's a dynamic model, we can think about the dynamic model in the context of like a Heckman labor supply model. So what would Heckman say that we need to identify like a standard static labor supply model? He'd say we need error correlation, we need something that's shifting around the decision to work but not influencing wages. And then because we're taking those wages and we're plugging them back into the utility function, we need something that's shifting around wages that's not shifting around, that wouldn't influence work decisions outside the shift in wages. And so all that is to say, those 3 things are currently missing. Now the good news is that like this is not a hard change, right? You already have an unobserved heterogeneity structure set up. It's very easy for you to just allow that unobserved heterogeneity to enter into the employment and school preference equation. Really, we're talking like 2 or 3 additional exclusion restrictions. It does force you to estimate everything in one step, which means estimation takes a little bit longer. But all of this is like totally feasible. And once it's done, I think like your identification argument's buttoned up. Okay, so getting to summary of estimates, almost all the parameters are like totally sensible. The model fit is great, just trust me on that. I'll point out a couple that I think you want to pay attention to. All right, when I think about like the core endogeneity problem in a paper like this, I would think there are some people who just have, they have a rough upbringing, and those people are more exposed to bad mental health shocks, and they're more exposed to bad outcomes in the labor market. And so when I go and look for unobserved types, I'm like looking for that bad type. Like, show me the evidence in that the model is able to pick up on that person. And right now, you're finding a healthy type and an unhealthy type, but there's no real correlation with the labor market outcomes. I think it's because you just need those types to enter the utility function, and you'll end up seeing that there's some subset of poor health types that also like choose not to work. So that's missing right now. And then, as I said a second ago, because you're not accounting for the full-time work in the mental health, or in the health equations, we end up finding these like really, really big effects of working on the health transitions. That said, there's a bunch of sensible magnitudes regarding health and income where you are focused on modeling that unobserved heterogeneity. You find that an additional $1,000 in annual income increases the probability of good mental health by like some positive amount, but not like a crazy amount. You also find that when someone goes from a bad mental health state to a good mental health state, their income, again, increases, but doesn't increase by like an absurdly large amount. So all that's good. Okay, so the bulk of the paper is, or at least the bulk of the back half of the paper is counterfactual analysis. For all of these, imagine them taking their data, taking the initial conditions, giving everyone in the data 100 sets of draws, and then forward simulating life paths along each of those. There's going to be two big things that they're going to calculate over and over again in the simulations. One, on any particular simulation, they can calculate the present discounted income, right? So just taking income over the lifetime and discounting it back, adding it up. And then for any two simulations where they change something in between the two simulations, they can make an equivalent variation calculation. So they can, this gives us a sense that whatever they tweet, they're measuring this is like the welfare change in light of the tweet. Okay, so here's their first set of counterfactuals. Focus on the right, or the center and the right column. The center column, they're going to take everybody in the data, and they're going to assign them the poor permanent health type. And then in the right column, they're going to assign everyone the good permanent health type. So this is like the unobserved health type. And the two things to highlight is the lifetime income difference between the two health types is that 10.6%. So if someone is in that good health type relative to the bad one, they make 10% more money over the course of their life. Moreover, they can calculate what would somebody pay to get to move from the bad permanent health state to the good permanent health state. And the amount is like the 200 and something thousand thing, but the percentage increase is 31%, right? So they would pay 31% more than what they currently do. Okay. All right, so the next set of simulations, they're going to take everybody in the data. They're going to simulate their life cycle at baseline. And then they're going to go in and they're going to say, in the very first period, I'm going to put you into the poor mental health state. They'll do it again and say, I'm going to put you into the poor physical health state. And they'll do it again and say, I'm going to put you into the good mental health state and in the good physical health state. All right, so at the top, the initial mental health, the top red small bar, that's when they put them in the initial bad mental health state, and then they're going to calculate first, what's the lifetime income loss, and second, what's the lifetime welfare loss. And I think the big thing you're supposed to take from the top half of the figure is that changing just the initial health state, either physical or mental, it doesn't have a huge lifetime consequence, okay? The bottom half of the figure, again, they're going to simulate somebody's life cycle one time, then they're going to go back and they're going to say, what if you were in a bad mental health state in every single period over the course of your life? What's the welfare consequence of that? And so the long, light red bar says that the lifetime consequence of always being in a bad mental health state is like almost a 40% reduction in welfare. Okay, and then they do the same at the bottom with the physical health state on both sides. Okay, so I think the big takeaways is that across the table, or across the figure, the mental health impact is exceeding the physical health impact, and it's also the case that always poor mental health cuts the discounted income and the equivalent variation by a lot, by more than 20%. One thing I will point out here is a place, I know in mine and Nick's paper, like we do a lot of this, but we also have treatments in there. But something that we do that's very, very similar to your light blue bar here is we calculate for the US what would be the annual willingness to pay for a magic pill, where the magic pill is something that never allows your mental health to fall below some threshold. That's basically exactly what you're doing with the light blue bar there. So that's some benchmark from the United States that you could aggregate your figure up and see how far away you are. Okay, so the next thing they're going to do is they're going to think about transitory shocks at age 30. And they want to think about shocks to health and how those shocks to health influence labor market outcomes. And then similarly, how shocks to labor market incomes ultimately are made better or worse by health states. So for each one of these, they're going to do four simulations, a baseline simulation. Then they're going to do a simulation where somebody's in good health always. Think of that as being like there's a perfect treatment and somebody uses it anytime that they're not well. They're going to do another simulation where they hit somebody with a shock and then they always have to stay in a bad health state. That would be like all medical treatments went away and people are constantly spiraling into terrible health anytime something bad happens. And then whatever the model predicts. So that allows health to update in accordance with the circumstances. Okay, so the first exercise that they're going to do on the left, what's being plotted is the proportion of the population that's in full-time work. The black line is just baseline. So that just says like, on average, this population, 80 to 85% of the time, they're just in full-time work. Okay. The green line is these individuals get shocked with a bad health shock at 30. So that's forced by the researchers. And then the green line is plotting how long does it take for their full-time employment status to recover after this health shock. And basically this says it takes about 5 years for a 30-year-old on average to recover from a bad mental health shock. Okay? On the right, it's the same thing with physical health, and you can see there's just not much there. So people's employment isn't nearly as responsive to physical health shocks. Okay? Similar setup, but now the shock is you lose your job at age 30. So again, if we go to the left, the black line says about 80% of people are employed. At age 30, employment is going down to 0. The green line is the prediction for what the model says, how long it takes somebody to recover to full employment. You can see if they're persistently in a good health state, that's the blue line. It's not that helpful. It's not like they jump right back to employment. I think the bigger thing to take from it is the red line, that if somebody gets hit with this shock and they're always going to be in a bad mental health state moving forward, they're never going to fully recover from losing their job. Okay? I only have 1 minute left. There's another set of counterfactuals they do. The last thing I want to leave you with that I think both helps motivate the paper, but also is something that you could think about as you dream up new counterfactuals, is this really cool picture from a 2004 paper from Blanchflower and co-authors. So the black line here, so this is coming from Burfus data, so this is like telephone survey. They're asking people, I don't even know what the exact question is, but they're asking people something about their, where you could extract information about the mental distress that they're experiencing. The black line is showing across the age distribution the share of people that you would categorize as being in as experiencing mental distress between the years of 2009 and 2018. And then the orange line is the exact same thing, but looking at the years 2019 to 2020. So clearly, like, COVID's in the middle of this. But I do think it's, like, I've got a group of health economists in front of me. I do some research on mental health. This is something people should know about. Like, you should know about the fact that, like, for a very long time, the mental health profile across the age distribution looked a very particular way. It was this inverted U shape with this, like, kind of peak in midlife. And then in the past few years, like, this has changed dramatically. And I think this is something that as you dream up counterfactuals, like a real question here is, like, what are the future labor market implications of this change? And, like, you literally have a model that can help us think about that. So anyway, thanks for listening. And
Okay, so first, thanks to Chris. I'm sorry that you only get to discuss my bad papers. But I appreciate all the insights. So I have some answers actually to some of the questions. Some of the answers I feel embarrassed saying them because I will kind of say out loud my mistakes. But I want to just say that I fixed them. So the very first thing that I also noted is that you said no variation in. I am not going in order, sorry. I am picking up the kind of the most embarrassing things first. So we end up in a high. So the very first thing is it's true that I didn't find a lot of variation in the unobserved income types. I kind of most of the chunk of the data is kind of the high type. So I looked into this, and I have to say that it's my mistake. So when I checked the raw data for full-time and part-time wages, I saw there was kind of a small mass close to zero. So yeah, I mean, this is answers from surveys. So some people say, yeah, I am working full time, and how much, in the last, I think they asked in the last 12 months or in the last week, what was your weekly salary? And they answered zero. So, and then what I essentially does not to take too much time, when we Winsorize to essentially 1% and the wages for full-time and part-time, then we re-estimate the model in 2 stages, not the new corrections that Chris suggested. Then we get a more, reasonable split of high and low income types. I think it's about 30-70%. So that was kind of my fault. So I'm glad that I fixed that. So that's kind of the only embarrassing thing. The other 2 things I want to say is I'm glad that I am aligned with some of the suggestions. So the reason we started with the 2-stage model is first, just because it's more convenient from an estimation point of view. It just takes shorter amount of time. Also because usually a structural economist not facing most of the time I don't face a structural audience, so they tend to not believe the estimates and all the parametric assumptions that we make. So I found, I was thinking of having this kind of 2-stage model in kind of an appendix and showing that, okay, you don't believe the full model, but at least believe my first stage estimates that are not driven by parametric assumptions in the utility. So that's how I picture it first. But it's true that we are lacking this raw, let's call it ROI model. This is not the words that Chris used, but this idea that the selection of people that could have high income potential in the future, they are not positively selected into schooling. So it's true that the way to address it is through some adding heterogeneity in the utility, and actually in the new version we have kind of factor loadings multiplying the income types for the utility. So, and of course now the estimation is in 1 step. I am still, in the appendix I am still saying that I think the model can be still estimated in 2 stages under some assumptions, but I am doing a one estimation now. So those are the suggestions that I think I kind of already covered without knowing them. But I take positively the suggestion of starting a little bit early to capture some of the effects of mental health even before completing high school. And actually I was surprised when Chris told me last night the share of mental health problems before 18 and after 18. I have to admit that because I started from the sample above 18, I didn't check in my data what was the share before 18 of having any mental health disorder. So I am, notably, there is clearly some differences in the share, which, is not just allowing the model to fit more age, I think more years of age. I think there is a meaningful, difference between early ages and, pre-18 and after 18, which I think it makes it reasonable to include it in the model. And I can do it with the same machinery I already have. So that's great, I guess. The threshold of severe illness versus mild versus good, I actually kind of agree. I think the most of the trend that we have seen lately is about mild anxiety and depression, and it's not being fair to put together kind of severe cases versus mild cases. And I am looking forward to see how the estimates from Australia compare to the US. I know that in general, it's the severe cases which actually affect future lifetime trajectories, and not a lot the mild cases, or at least this is evidence from the US. So I am planning to include this for the Australian data. What else? See, I am agreeing with some of the identification challenges here. This is something we have discussed. Do we need two instruments or not? So I think I have reasons to convince myself that we need two, but there is a back and forth between our discussions. And the truth is, maybe we can solve the problem because we have too many good questions in the Hilda data that we can potentially leverage as shocks separately for mental and physical health. So that's something I can check. What else that I have that I wanted to? And thanks for the suggestion for the counterfactual about what would be the future labor market implications for the changes in the age profile of mental health. Yeah. Okay. Well, thanks.
I think this is great. Thank you for incorporating this into a model. Just trying to connect it a little bit to like Chris and Nick's work and the work that we just saw previously. I mean, it seems like there's a strong argument that people are endogenously managing mental health specifically with respect to keep them in the labor market. Right? So when I have a mental health shock, I go for cognitive behavioral therapy or pharmacotherapy, and as a result, I can manage my mental health and I can work. So, a few questions. So in Hilda, do you observe anything that would allow you to look at that? Any kind of antidepressant use, anything like that? And then just like generally, what would be the implications in your model if you allowed for that? If you had people simultaneously choosing to work and to manage their mental health in some way, how would that change your results?
Yes, so I can tell that we don't have great data in Hilda about any, medications or visits to the doctor or psychotherapist. So we are aware that people can get, are probably getting some people are getting some mental health treatment, and we are not modeling it, but of course the estimates are picking that effect up, right? So the way I would say I interpret this is we are allowing for let's say a lower productivity in your, like if you manage to still keep working, but with a bad mental health, I mean, that would reflect in a kind of a lower productivity and, while you're working, and hopefully that picks up some of the effect on wages. It is true that we cannot kind of see which people, it's on average, right? It's on average for everyone. We cannot say for the people who took the therapy or some sort of treatment. So I would say that's one of the limitations of the data, that we don't see anything related to health insurance, which is national in Australia, but take up of medications or visits to the doctor. So it will be hard for us to make a claim on that regard.
So I've been obviously following this paper for actually 3 reasons. One is because of Chris's and my work, I guess, and also I talked to Bart a lot, who's your co-author, and then also my student has a life cycle model of work decisions by using the NLSY. So there's an interesting, and I think I'm trying to still figure out how this we've all talked about this, so it's in parallel, but it seems like Australia does a better job of not derailing students' educational attainment because they're depressed. Because when we use the NLSY, that's kind of become the point of the student's paper, right? Is that education is endogenous to mental health treatment, in which case this is kind of the thing that Chris is saying, in which case, geez, intervening early can have a big effect because of this change on education. But I just wonder it would, like that then lead, so first of all, that's great, because there's the product differentiation, whatever. But it also like leads me to wonder, like, what is it about Australia that makes it so that you can be depressed or be anxious or whatever, but it's not gonna mess up your entire educational, because that's actually, that means that there's the counterfactual that, say, his name is Mark Rose, who's on the market. So in Mark's paper, he does a counterfactual where like somehow that doesn't happen, kind of breaks that relationship, and it's great because you're showing that in another country, indeed, that relationship can be broken. But it'd be great to know why, right?
Yes. So just as context for everyone else, so we don't find a ton of effects of poor mental health on schooling decisions. And for us, schooling, just to remember, it's a college or grad school because everyone has completed high school in the current sample. So we don't see a ton of effect of poor versus versus good mental health for schooling, but we see all the effect or most of the effect on employment and income, and with data from Australia. So yeah, I think it's interesting to go back and see what are the differences in the health insurance systems or the way they cope. They kind of cope with these mental health problems. I actually don't want to say new things because we have estimated this kind of ROI model now, and we see some potential. So we are finding preliminary, positive correlation between kind of high income type and schooling. So probably that will create a little bit of impact on schooling from mental health. But I would be interested as well, and I think it has to be related with the healthcare system somehow, right? I mean, because sorry.
Or the lack of it.
Yes, I mean, because Nick, remind me, the student is doing also high school completed?
Yeah, he looks,
I mean, that's the part, I'm not sure.
High school completion.
Okay.
And then, I think, because he starts when they're 16.
Okay, so I will be interested to see if the effects are mostly on high school versus college, but yeah, I understand there were differences. Yes.
Yeah, they're different enough, that's great, and I think it's good that there's multiple papers, but it's just like,
Yeah, from
if someone
where?
in the audience is like, oh, I don't believe that you can just like fix kids' mental health or break the relationship between mental health and schooling, it's like, well, you can, actually, because there's other data
Because
sets
there
in
is a
other countries
successful
where-
story from
where
other
they
countries.
Don't have that relationship, right, so that's kind of.
Yeah, thanks.
In Australia, you can get, I think the system of treatment for mental health is a lot better.
That might be the answer, right?
So you, like an 18-year-old would just have to go to the GP and they can get a treatment plan where they're gonna get free mental health care for 12 visits, and if they're still having problems, they could just go back and get another 12. It's much more easy, I think.
Sorry, you already. So, I was curious as I read the paper and then listening to Chris about it would be cool to see some kind of visualizations to see to what extent there's scarring from somewhat temporary mental health episodes. But like if somebody has at different ages, that if somebody has not necessarily, they may not be the permanently low mental health type, but if they go through an episode after they're done with school when they're in the working world, right? Does that serve as like an intercept shift with their lifetime wages, or is that relatively transitory, or does it lead to divergence? Does that matter if it's at 25? Does that matter if it's 30? Because there's some cool features that you could bake into this that would be really kind of fun to explain different extents that transitory mental health episodes create scarring or divergence. But I think just kind of looking at some of that from a descriptive standpoint would be cool, and one version of the world that tells your reader that these are not the droids that they're looking for. And the other one that gives you some neat rocks to kind of pull that thread.
Yes, I think I have all the elements I can do. I can do something like that.
Okay.
Yeah. Thanks.
I just looked at, all right, so I think it's great that you're looking at the effect of employment and anything on mental health, and obviously vice versa. But are there other dimensions of work that could impact mental health that maybe even get at some of these things that Pat's talking about, like hours of work or an occupation? Maybe people go into one occupation and they experience this is not for me, and then they get out and get into another occupation. Is there a reason why y'all chose to just look at work or not work for school?
Yes, we started so to be honest, we started first with entrepreneurs versus paid employees. That's how it started. Then I have to say we didn't see, we saw more impact on the paid employees than on the entrepreneurs. So we decided to go to paid employees and then separated by, kind of hours of work if you want in part-time and full-time, but we discretize it in the hours of work if you want. But yes, we have definitely the hours of work and we have the occupations. And do you think there will be some interesting kind of, conditional on your, well, discretize it.
Occupational schools would be much harder, but.
I can look into that, but definitely hours of work. But we are capturing in a way hours of work with part-time and full-time. I mean, very discretized and stylized way, right? So I think if there is anything kind of new to add, it will be maybe occupation or some characteristic of the task of the job.
Right, and the Hilda data has a lot in that. One of my students, do y'all remember Tan looked at, they asked questions where you can use like the occupation, what is it you used?
ONET.
ONET, you could use the ONET to classify different types of occupations, but then they also have self-reported stress measures.
Yeah, so I want to not to advertise the other paper. I mean, but the student of Nick actually looks into. My understanding is that looks into some index of stress for each type of occupation. So I in the U.S. right? So that makes sense. Okay, because I can see how the transmission works. So yeah, I think we can do the same, right? In a way, but yeah. Okay, thanks for the suggestions.
We have a couple of minutes, please.
Go ahead. The presentation focused a lot on work. What about if a shock causes you to leave school? How big are those effects?
So we didn't run that counterfactual. We just shocked we moved you to unemployment unexpectedly, and we moved you to poor health unexpectedly. We didn't kind of make you drop out from school unexpectedly.
I think for this age group, it's maybe even more interesting to look at the school. What's the effect if one of these shocks induces you?
Totally, I agree.
Especially with the extension to the 15 years, because
It will be a clear high school degree versus non-high school degree.
What is implication of this model for these really important dynamics that you think would plug into the kinds of variation that we use in quasi-experimental studies that would make it some of the aspects more testable? And the flip side of that is, what are some parameters or relationships you think would be most useful to pull out of future quasi-experimental studies to help pin down what you need to specify a full model?
So I'm not sure if I get the full question, but so for example, I think in general, this idea of what most quasi-experiment studies are giving us is what is the short-term impact of a shock, of a mental health shock, or a labor market shock, or a schooling shock, right? So what is the short-term impact? And I think there is in essence nothing you can do with a short experiment to quantify what are the long-term impacts on after temporary shocks, right? The long-term impact of temporary shocks are just harder to see. So I would say in that case, there is a complementarity between quasi-experimental work and structural work, and actually we are using that to identify our parameters. The other thing that I think it will be interesting is in a measurement way, to get measures of mental health. Not every data set has those measures. So if I am about to start a new experiment now, so I would say collect measures of mental health differently than measures of physical health, and potentially these shocks to health, because the reverse causality is just hard to identify. That's why many papers just model one-way causality, right? So breaking that causality is through collecting some data, right? So I don't know if that answer. I mean, we can chat more, but I would say both approaches will be complementary. I don't think one can substitute the other one, right? Well, actually, if we want to measure some welfare effect, I would say the extreme case can be, you know, kind of survival or something like that. Like you know, so what is Amanda, right? So you know, if you can measure survival, you know, some very extreme outcomes, even from the experiment, that will definitely even improve my paper, because I don't see people for so long in my data. But yeah.
Okay, why don't we end here? Thank you.
Thank you.